Hello everyone, welcome to my YouTube channel. In this week video, I'm going to explain to you how you should answer quiz 1 question consists of gas law. So altogether we have 5 different questions and let's start with the first one. Question number 1. Calculate the volume occupied by 12.5 gram of carbon dioxide gas at a temperature of 40 degrees Celsius and a pressure of 1.2 atm. To answer this question, the first thing that we need to look at is the atomic mass. So atomic mass for carbon and oxygen is equal to 12.0110 and 15.9994. So from here, we need to calculate what is the relative molar mass. The relative molar mass of CO2 is equivalent to 12.0110 plus 2 times 15.9994. Therefore, you will get your RMM equivalent to 44.0098. So this is the first step. So the second step that we need to look at is to calculate what is the number of mole for the carbon dioxide. So number of mole is equivalent to mass over RMM. So in the question, you were given the mass of carbon dioxide, which is 12.5 gram, divided by 44.0098 gram per mole. Therefore, you will get the number of mole of carbon dioxide is equivalent to 0.2840 mole of carbon dioxide. Alright, so next up, what we need to do is we need to look at the question again. It asks you to calculate the volume. So you have already calculated the number of mole. Therefore, we can use an ideal gas law formula, which is PV equivalent to nRT. Therefore, the pressure is given in the question, which is 1.2 atm. And the volume is what you want to calculate. N is 0.2842 mole, and your R is a constant, gas constant, so 0.0821. So please remember the unit is liter atmosphere divided by mole Kelvin, right? And then the temperature is given to you, so make sure that you convert the temperature 40 plus 273 so that you will get the unit, which will be in Kelvin. So basically, what we can do now is we can slash out all the unit. So we have mole over here, and then this one is Kelvin. Alright, so you are left with liter atmosphere. So we can say that for the volume, you have to calculate this and you will get 7.2980 liter atmosphere. So you divide with this one, 1.2 atm. Therefore, you are going to slash out the unit, and then you will get the volume to be equivalent to 6.0817 liter. So this is the final answer for the first question. So let's move on to the second question. What volume must a syringe be changed to if the pressure increases from 1 atm to 3.5 atm while the end of the syringe is plugged and no gas can escape, given that the initial volume of the syringe is 10 centimeter cube? Alright, so this is a rather straightforward question. You were given the initial volume for the syringe is 10 centimeter cube. So the first thing that you need to do is you need to convert the centimeter cube into liter. So 10 centimeter cube. So you want to convert it to liter, so you need to divide by 1000. Therefore, you just have to move 1, 2, 3 over here. So you will get 0.010 liter. Alright, so if we look at the question, you will ask what is the final volume. So the best formula that you can use is P1V1 is equivalent to P2V2. So the initial pressure is 1.0 atm, and the volume is what you have just calculated, which is 0.010 liter, is equivalent to the final pressure 3.5 atm, and you want to calculate what is V2. Therefore, your V2 is equivalent to 1.0 atm times 0.010 liter divided by 3.5 atm. So from here you can slash out the unit, and then you will get your V2 is actually equivalent to 2.8571 times 10 to the power of negative 3 liter. So this is the final answer for the second question. Moving on to question number 3. A gas mixture comprises 1 mole of hydrogen, 3 moles of ammonia, 10 moles of carbon dioxide, and 6 moles of nitrogen, exerting a total pressure of 80 torr. Calculate the partial pressure for carbon dioxide in the gas mixture. Alright, so the first thing that we need to do is look at the unit that were given to us. So the rest are in moles, that's fine, but then when you look at the pressure is in torr. So basically what you need to do is you need to convert this into atm. So 80 torr, you need to convert it to atm. So basically 1 torr is equivalent to 0.001316 atm. Therefore 80 torr, you just have to do like 80 times this figure, 0.001316. Therefore you will get 80 torr is equivalent to 0.1053 atm. So this is the first step for this calculation. Okay, so next up, what we are going to calculate is the total number of mole. So total number of mole is just the summation of the number of moles. So we have 1 mole plus 3 moles plus 10, and also the last one is 6. So you will get the total number of mole is equivalent to 20 mole. Right, so now because we were asked to calculate what is the partial pressure of carbon dioxide, so we are going to look into carbon dioxide only. So because we know what is the total number of moles, so we can calculate what is the mole fraction. Alright, so for the mole fraction, because you were asked to calculate the mole fraction for carbon dioxide prior calculating the partial pressure of carbon dioxide, so the mole fraction is equivalent to the number of mole of carbon dioxide itself, so it's 10 mole divided by the total number of mole, which is 20 mole. So you will get the mole fraction of carbon dioxide is equivalent to 0.5. Right, so next up is how you are going to calculate the partial pressure. So the partial pressure for carbon dioxide is equivalent to the mole fraction of carbon dioxide times the total pressure. Right, so the mole fraction is 0.5 times the total pressure, this one we already converted just now, is equivalent to 0.1053 atm. Therefore, your partial pressure for carbon dioxide is actually equivalent to 0.05265 atm. So this is the final answer for the third question. Let's move on to question number 4. Upon reaching equilibrium at 472 degrees Celsius, a mixture of hydrogen and nitrogen gases in a reaction vessel was measured to have a partial pressure of 7.38 atm for hydrogen and 2.46 atm for nitrogen and 0.166 atm for ammonia. So using this data, calculate the equilibrium constant Kp for the reaction. Alright, so in this question, at the beginning it states that hydrogen and also nitrogen gas were reacting with each other until it reached equilibrium. But then there's a clue in this question whereby when they give you the partial pressure, they give the partial pressure for hydrogen, nitrogen and also ammonia. So indirectly saying you were asked to create a balanced equation, a balanced chemical equation with the reaction between hydrogen plus nitrogen to produce ammonia. Alright, so what you need to do now is to make sure that you balance your equation. So if you put 3 over here, it means that you have 6 hydrogen altogether. So to have 6 hydrogen, so you need to times 2 over here. So when we check back, we have 2 nitrogen over here, and indeed we have 2 over here. Therefore we can say that this equation is actually balanced already. Okay, so next up we need to list down the partial pressure. So we have partial pressure for hydrogen, nitrogen and also ammonia. So from the question we know that the partial pressure of hydrogen is equivalent to 7.38 atm and then 2.46 atm followed by 0.166 atm. Alright, so you were asked to calculate what is the equilibrium constant, so Kp. So Kp is for gaseous form only. So we assume that all this should be in gaseous form. Therefore, we can find the Kp, whatever in the product. So partial pressure of ammonia, but here we have 2, so to the power of 2 divided by the partial pressure of hydrogen, because here we have 3, so to the power of 3 times the partial pressure of nitrogen. So we don't have any other number around here, so we are going to write it as is. So what you are going to do now is plug in all the values from here. So you will get the Kp is equivalent to 0.166 square divided by 7.38 cube times 2.46. Alright, so you should get your Kp is equivalent to 0.0276 divided by 401.9473 times 2.46. So you just have to press your calculator and you will get your Kp is equivalent to 2.7913 times 10 to the power of negative 5. So this is the final answer for the 4th question. Alright, we are now at the final question for this week video. Given that 0.822 mole of SO3 is initially placed in a 1 liter container at 600 Kelvin and 36.7% of the SO3 decomposes when equilibrium is established, calculate the pressure of SO3 at equilibrium. Okay, the first thing that you need to do is look at the percentage given to you. So given in the question, 36.7%, so 36.7% from the initial number of mole from 0.822 is being used when it reach equilibrium. So you need to find the value of this. So it is equivalent to 0.3017. Right. So this is the number of mole of SO3 that is being decomposed. But initially you have 0.822. So this is the initial, and then this is how much that have been decomposed. So 0.3017. So you minus that. So you will get 0.5203 mole of SO3 still available, right? So it asks you to calculate the pressure of SO3 at equilibrium. So at equilibrium, this is the number of mole of SO3 that is still exists. So you can use the ideal gas law, PV equivalent to nRT, to actually find what is the pressure, because in the question you were given that this SO3 is being put or kept in a 1 liter container. So you will get your value for the volume, and then it is put at constant at 600 Kelvin. So you already know your temperature, you already know your number of mole, and R is the gas constant. So you just have to plug in the values and you will get what is the pressure at equilibrium. Alright, so now we are going to use the ideal gas law, PV equivalent to nRT. So P is the one that you want to calculate, your V is 1 liter, your N is this one, 0.5203, your R is a constant value, 0.0821 liter atmosphere divided by mole Kelvin, and your temperature is 600 Kelvin. So here it's supposed to be mole, right? So what we can do now is slash out all the units that we do not want, and then the volume should be in liter. Okay, so you will get 0.5203 0.0821 liter atmosphere, 600 divided by 1 liter. So this liter, so end up your unit should be just in ATM, and then you just have to click on your calculator. You will get 25.6299 ATM. And that is the final answer for question number 5. We have come to the end of this week's video. I would like to thank all of you for watching this video from the beginning until the end, and I hope that this video will help you to understand more on how you should answer questions from chapter 1. So I'll see you again next week. Take care and be good. Goodbye.